right here today to take you through some practical item of chemistry. At least we are done with mock papers. We've attempted a number of sets, I know, from our previous schools. We have seen a number of questions. Most of us were able to rate, and I know there are some people out there who cannot rate anything, who do not know where to start, who are not able to get a chance of having such questions. Members, are making these questions for such people and those people out there who attempted them, but they really don't know what they did. So what we are giving is a proposed guide on how you would attempt some numbers. I'm online, and my name is Teacher Alan once again. Members, to cut the story short, don't forget to subscribe, to like our videos if you really like them, to share them to your other friends. Members, don't forget to put the questions in the comment section, supplements, suggestions. Welcome everything. Today, Friday is with us as always. Is the earliest bird. Don't forget to comment, members. To cut the story short, we are going to do a number that has appeared in a number of mock sets, including the successful mocks. I've got actually a chance of seeing a number of mock sets with this number. This number also appeared in Wakissha as paper 2. The number reads, wash and wear a laundry service provider in one of the Kampala city suburbs has to choose the best water source for effective washing with a new soap brand on the market. Its manager has contacted 2 water suppliers from the area, but he does not know which of the 2 water sources will minimize wastage of soap and cut down the costs of soap. You are provided with the following. F, which is 80 cubic centimeters of water sample from source A. T, which is 80 cubic centimeters of water sample from source B. BA1, which is 150 cubic centimeters of soap solution. A burette, a pipette, and other laboratory apparatus. So, members, the question is all about the reaction or the interaction between water and the detergents, strictly a soapy detergent. So we have students out there who do not know how a burette looks like. This is a burette. They told us to prepare for you water sample F, and this is our F. Water sample T, this is our water sample T. They told us to prepare for you a soap solution labeled BA1, so we have it right here. To provide you with a pipette, I don't like pipetting. I would alternatively use a measuring cylinder, but they told us to provide you with a pipette, so we should have it. They told us to provide you with a conical flask, so it's right there, and a retort stand as well. So we have a retort stand right here. So members, when we go through this item, the item is all about the interaction of soap or a soap detergent with water samples, strictly hard water. Members, to cut the story short, hard water consists of magnesium or calcium ions as the cations, and then sulfate or hydrogen carbonate ions as the anions. Members, if for example, soap is sodium stearate, if the magnesium ions or calcium ions in any sample, any hard water sample, react with an ion, for example, if it is a stearate, if the soap is sodium stearate, it will form magnesium stearate, which is an insoluble salt, or calcium stearate, which is an insoluble salt. If the salt is, if the soap was a stearate soap, so this one will appear as scum within the water. This kind of water make it difficult for soap to form lather with it. If it contains either calcium or magnesium ions, it becomes too hard for this soap to make lather with it. Why? Because the soap will first of all has to react with the magnesium or calcium ions within the water samples, the hard water samples, to form this scum, until when all the magnesium or calcium ions are over. It's when the soap will start now reacting with real water without the ions to form scum, to form lather. So the water has to first, this detergent, the soap detergent, has to first react with all these ions in the hard water sample, forming a precipitate that is appearing as scum, white solids in water. And once all these ions, the calcium or magnesium ions, have all formed a precipitate and the water is free from them, that is when we shall remain with water without them, and that water will react with the soap or the ionic part or the hydrophilic part of the soap detergent to form lather. So if these ions still appear in the water sample, we don't expect to form lather that is permanent. So this practical, it's all about determining the amount of magnesium or calcium ions in the water sample. A water sample with more of these ions will require more of the soap solution to displace all the magnesium or calcium ions from it so as to form lather. So the one that is having more of these ones will require more of the soap solution. And this kind of water sample wastes soap. So it is not an effective water sample for that roundly purpose. I think that background is okay. To read through the item, we all know how to form, to generate an aim, I think. If you don't know, please try to get it from here. For part A, they told us to plan and design an investigation. But in the brackets, they are telling us that we include the aim, the hypothesis, the variables, apparatus and materials, procedures, then risk and mitigation on part A. So members, the aim, don't forget that The aim is the reason to why you are carrying out the investigation. From the scenario, which is already in the description of the video, it is stating clearly that the laundry service provider wants to, has contacted 2 water suppliers. One supplying water from source A, that is F. F is a water sample from supplier getting the water from source A, and T is a water sample from a supplier or getting the water from source B. So we want to find which of these 2 water samples do not waste soap. Oh, which of these 2 water samples require less of this soap solution BA1 to form lather, permanent lather? All those two statements mean the same. So based on the scenario, the aim is already indicated in the scenario. So the aim, according to me, you can also write yours in the comment section. We shall read it. According to me, mine would have been to find out which of the water samples F or T require less of soap solution BA1 to form lather. According to the scenario, I think that is the water sample the manager of the laundry service providing company wanted. And the one that forms lather easily with these water samples, with this soap solution, will be the effective cleaning water sample the servicing provider or the laundry company needed. You can suggest your other aims. Find out which of the water samples, F or T, is more effective for cleaning. You can suggest all those aims you have. So we said the hypothesis is a theoretical prediction of results. The hypothesis, I may just say that water sample F or T is effective for cleaning. Alternatively, you can say water sample F or T does not waste soap. Water sample F or T requires less amount of soap solution to form permanent lather. All those statements mean the other aim or target of the company. So I just predicting, I've given a general hypothesis. I'll prove it after the investigation. In the conclusion I will make. So I've made one that is open. The next thing is stating the variables. We have, among the variables, we said we have the controlled variables. And remember, we said controlled variables are the ones we keep constant in the investigation. For these items or practicals of soap with hard water, we shall always make sure that the volumes of the water samples we use will always be kept fixed or constant. If we use, let's say, 20 of F, it is the same volume of T we shall use. So the volume of the water sample used will become our controlled variable. Then the independent, we said the independent variables are those variables we change so that we can get results. We keep on changing so that we can get results. Members, what I've just explained previously, for these kinds of investigations where we are using, we are comparing two water samples, our independent variable will always be the type of water sample used, or alternatively will be the amount of ions in each of these water samples, or concentration of ions in the water samples. So our independent variable will be the concentration of ions in water samples F or T used. So the concentration of the ions, we talked of the ions responsible for hardness of water. They are the calcium or magnesium ions for the cations, then sulfate or hydrogen carbonate ions for the anions. So the concentration of the ions, we said, will determine the volume of the soap solution used, because at the start of the video, I indicated how soap or a soap detergent interacts with hard water. The advantage of such lessons, members, you can pause, you can forward, you can rewind. And I have suggestions here. But is suggesting an aim, is saying to determine which of the water samples T or F forms permanent lather easily with soap solution, BA1, that is okay. That is very true. Members, we welcome Famao Wataba. We welcome Kigongo Elia, Semata Elia, most welcome. Naninde Lydia, you're most welcome. Padre Sebuf, you're most welcome. And others in the background, you're most welcome. Members, to continue, you can suggest your other variables. These are mine. We have the dependent variable, and you said a dependent variable, we said they are the results of the investigation. They are the ones we take as results. The dependent variable for these kinds of investigations of soap detergents with hard water will always be the volume of soap solution used. Now the soap solution, they told us it is PA1. So it will be the volume of PA1 used. At the start of the video, I explained the theory. So this kind of a practical, I'm going to try to narrate it as we get the apparatus and the materials we need. For this kind of practicals, we shall always suspend a burette on a retort stand. So we shall always have a retort stand well suspended. A burette well suspended on a retort stand. Members, if you are as tall as me, you should always make sure you adjust the retort stand to your height. This is my height. Make sure that every part that has to be adjusted is firm. So this is the first procedure, is suspending a burette on a retort stand. We then get our pipette and transfer. I'm going to use a measuring cylinder. Transfer that volume you decide. For example, if you're using a pipette, you transfer the volume the pipette can accommodate. The pipettes are usually 20 or 25 for your level. So I will start with one water sample. Let's say I'll start with F. I will transfer 20 cubic centimeters of F using a pipette to a conical flask. So this is the conical flask. Then after transferring the 25 or 20 of the water sample, one of the water samples into a conical flask, I will run a soap solution that was previously added into a burette, a 0 cubic centimeter mark, onto the water sample while shaking. So I'll add the soap solution from a burette to the water sample in the conical flask while shaking until when I form a permanent lather. Permanent lather. That point where the permanent lather is formed, I'll close the tap of my burette and then read the volume from the burette of the soap solution. So I first of all recorded the other initial volume. It was my 0.0. That becomes my initial burette reading. I will then record the new or the final burette reading after forming the lather or after adding the soap solution to this water sample. I will read the new volumes from the pipette, from the burette as my final burette reading. When this solution just forms lather, that is when the soap is now reacting with water free from the other ions. The ions will have solidified to form scum with soap. I will repeat this procedure after powering and washing or cleaning the conical flask until when I get consistent result for each of the water samples. So for F, I'll make about 3 values. I will repeat the same procedures for T. The procedures I'm talking of is I have the soap solution in a burette on a retort stand at 0.0 cubic centimeter mark. I'll use a pipette to transfer 20 cubic centimeters or 25 to a conical flask. Then run a soap solution from a burette a little at a time while shaking until when a permanent lather forms. I will take the readings of the new burette readings and record them as my final burette reading. Then repeat the same procedures until when I get consistent results for a particular water sample. I think we are following. We are going to do it practically. You are going to see it coming out. So those are the procedures. That means that the apparatus, they are the materials that help us get a product. So the apparatus, we've been talking about them, a retort stand, we are seeing a conical flask, a burette, a pipette, which I will alternatively use, a measuring cylinder. So we shall need a burette, we shall need a conical flask. I need one, I think one will be enough. Let me use two. Two conical flasks. And I will also need two pipettes. One for transferring water sample T, and the other will be for transferring water sample F. Not to interfere with the amount or the concentration of ions. I'll also need a retort stand to suspend my burette. I think those are the ones. And then the materials, we have the water samples, F and T, and then the soap solution, BA1. I think those are the ones. So don't forget to put the materials, because the question is clearly stating or telling us to separate them. So we have the materials as water sample F and T, and then soap solution BA1. The materials are the requirements that will be part of the product. The procedures or the procedure, we've just stated them. Remember we said we write them in a reported format. And in past tense, we don't praise ourselves or command the examiner. Hope you all hear me well. So the first procedure was to suspend the burette on a retort stand, and then we add the soap solution to a 0.0 cubic centimeter mark. Remember, this is a burette. Its values are recorded to 2 decimal places. After that, we use a pipette to transfer. We are going to use 20 for this time. To transfer, let's say, 20 cubic centimeters of any water sample. We are going to start with F into a clean, empty conical flask. We shall then go on, run a soap solution from the pipette, from the burette into the water sample F in a conical flask while shaking until permanent lather is formed. Like I'm going to see. We shall read off the new burette reading and record it as our final burette reading. So after that, we shall obtain the volume of the soap solution used by subtracting the initial bullet reading from the final bullet reading. We shall then repeat the procedures above until when we obtain consistent results using this water sample F. And then we shall repeat all those procedures above up to this last one using water sample T. So that's what we are going to write. Our results will be put in a table. Please, you can suggest your procedures. This is not the end. Suggest your procedures. I will start by a bullet was suspended on a retort stand. Members, don't forget this is online. Don't forget to subscribe, to share, or like the video if you really like what we do. BA1 was then put into the bullet to a 0.00 cubic centimeter mark and recorded as the initial bullet reading. So we are going to suspend our bullet on the retort stand. We add a soap solution. We add a soap solution until when the soap solution is at a 0.00 cubic centimeter mark. Here's the 0.00 cubic centimeter mark. Here it is. So we record that 0.00 cubic centimeter as our initial bullet reading. So that is crucial to be noted as well. So what next? We shall, using a pipette, 20.0 cubic centimeters of, this time it is water sample of water sample. I'm going to start with F, was transferred into a clean, empty, conical flask. That is my next procedure. To continue, we said after this, we run a soap solution from the bullet onto the soap solution in the onto the water sample in the conical flask. So BA1 was ran onto F while from the burette while shaking until permanent lather was formed. So that is our next procedure. After permanent lather is formed, we say that we always read that volume from the burette and record it as our final burette reading. The new volume burette reading was recorded, was obtained and recorded. So I'm using was because we write the procedures in a reported format. The next procedure, we said that the volume of BA1 used was obtained from subtracting the initial burette reading from the final burette reading. So you are writing, you are reporting what you really did. We said we are going to repeat these same procedures until when we get, using the same water sample F, until when we get consistent results. Members, we at least do 3 values for each water sample. So the next procedure, we shall just say the procedure were repeated until were repeated using water sample F until consistent results were obtained. So repeat the procedures until when we get consistent results. And then these same procedures from here to here are going to be repeated, this time using another water sample, which is water sample T. So I will say all the procedure above were repeated using water sample T. So all these procedures of suspending the burette, it is already there. I've added the A1 to the burette to a 0.0 cubic centimeter mark. I've recorded it as my initial burette reading. I'm repeating all this procedure, this time using water sample T. Remember, as we said, if you are not part of our WhatsApp group and you would like to join, please contact us via 0703 278 231. This is our WhatsApp number, the online WhatsApp number. For any assistance, for inquiries, for suggestions, that is our WhatsApp number. You can reach out to us. Are you home stranded with books? You would like a teacher? Please reach out to us. Are you an adult tired of class? Or you would like to get an extra information about anything? You can still reach out to us. We shall always be of great help. Members, I'm not going to give risk and mitigation. You can think about it. You can even put them in the comment section. We shall be seeing them. Mwangs Emma, you're most welcome. Twahirwa Jordan, you're most welcome. Thank you for being part of the family. To continue, I'm just going to give the results. I will not give the risk and mitigation. I'll give the results. And this is our part B of the item. So we can talk of the volume of F and T used as one of the results. Remember, as much as you wrote everything in the scenario, in the procedure, it is also crucial you present it here. So I'm going to present all the variables we used here, specifically the dependent, controlled, and independent. So we used the equal volumes of F and T. Me used 20. So members, a pipette reads, or we record the values of a pipette to one decimal place. Then we shall have a table as well of the independent and the dependent variable. This was our controlled variable. What we kept constant was that one. So outside the table shall be rating the controlled variable. So here we shall have the experiment number, for a certain water sample. We have 2 water samples. That is strictly T. Let's say we have F and we also have T. We said we shall have three. Let's have a minimum of 3 experiments for each water sample. Experiment 1, 2, and 3. Even for this 1, 2, and 3. Members, values of the burette are written to 3 decimal places. Let me make a bigger table. So we have water sample F. We said we shall have at least 3 values for each water sample. So this is 1, 2, 3 for F. Then for T, we shall still as well have 3 experiments. That is 1. I think that is it. So we shall have the final burette reading, and the burette reads, it is a volume measuring instrument recorded for each of the experiment number for each water sample. We shall have the initial burette reading for each of experiment number and the water sample, and then the volume of BA1 used will be obtained in cubic centimeters. Members, make a decent table, well closed. Use your pen and ruler well. Make a very decent table. So members, with this, I'm good to go and use my apparatus to get results. I have where to record my values. The procedures I wrote are fulfilling this first table, but I have a step where I stated that all the procedures I did to get this first value are going to be repeated, so that, until when I get consistent results, I'm very sure by the time I do the second and the third, I will have obtained confidence. One, I will already be knowing at which volume did the solution start making the lather, permanent lather. Members, for each water sample, the volume in the tables or the experiment numbers should have not been bigger than or less than the other by more than 0.2. If your first volume, let's say, is 10.0, the other shouldn't have been small or bigger than this one by 0.2 or by more than 0.2 big, or 10.10, or exactly as this one. Or less than this one by this figure for accuracy for each of these water samples. So the next one shouldn't have been less or bigger than the first value by more than 0.2. So I'm going to call out the procedure. We said the first procedure, we said is suspending the burette on a written stand. I've just done it. So that was my first step. And in my first procedure, I'm going to add, or I'm going to transfer my soap solution into my burette. I'm not that tall to get to that height. Ensure that the tap down is closed. So they told us BA1 is the soap solution. It's what I'm putting into the burette. I want to make sure that, now this is the lather we are talking of. We want to make sure that this lather forms in the water sample. That is when we shall get what we call the end point. So I'm not reading lather, I'm reading the water solution, the soap solution. So I've added it past the 0.0 cubic centimeter mark. I'll add just by opening the tap slightly so that so this means that it is at my 0.0 cubic centimeter mark. This is my 0.0. There it is. So this one becomes my initial burette reading. So my initial burette reading for this first one, for F, is 0.0. But a burette, we record the values of a burette, we put the small places. So I'll then use a pipette to transfer 20, because I decided to use 20 cubic centimeter of water sample F. I'm now on this procedure. So I've recorded, I've added my BA1 into a burette, and I've recorded the initial burette reading. So I'm now going to transfer, for this you should have been using now a pipette. For reasons I don't want to use now, I'm going to transfer it into a conical flask. So this would have been a work of the pipette, not a measuring cylinder. So I'm going to now to procedure 3. I'm going to run BA1 onto the water sample. While shaking. Until when I form permanent lather. I don't think we shall fail to identify lather when we have it up there. Until when we get permanent lather. I think this is not permanent because it is disappearing shortly. It isn't permanent, it disappears. Hope we are seeing. The lather is disappearing, it isn't permanent. So we shall add until when the lather we form does not disappear. So it will surely be evident that the lather we have formed is permanent. It is no longer disappearing. As we check, is the lather permanent? I think we can see the white residues in the mixture. These white residues is what we call scum. If we can see them very well, it's what we call scum. Is the lather permanent, members? Please put in the comment section. We said we add until when we form permanent lather, but it does not disappear like this one. So it is still disappearing. So it means this isn't permanent. So we shall keep on adding until when we form permanent lather. That even if we put it aside or the solution aside, the lather will persist. The lather is still disappearing. Giving it time, the lather disappears. It means it isn't permanent. We add until when we get permanent lather. That white solids you see in the water sample is what we call scum. I'm not looking at where the solution is coming from. I'm looking at where it is going. I make sure that every drop gets onto the solution in the conical flask. A point is going to be reached when surely permanent lather is formed. I think we still see the lather up. We need to form such lather that is permanent. I'm adding a little at a time. While shaking, I'm going to do only one value for this water sample. I want us until when we get permanent lather that hardly disappears, like you see the other one up. Members, you can say, is it disappearing or permanent? We said adding until when we get permanent lather that does not disappear. So you can put it, can we compare it with the first one we are forming previously? Is it disappearing like it was previously doing? Let's check. We judge, is it permanent or it isn't? I think this is permanent ladder. Even when we leave it for some time, the ladder still persists. And after that is achieved, we come and read the burette reading. What is it reading now? To me, it is reading, we are reading from up, it is 25.1. If you can see very well, it is reading 25.1. Yeah. I think we can all see 25.1. And the ladder is still persisting, even up to now. It means that is permanent ladder. Not like the previous one that was forming. So this means our final burette reading is 25.1. So we add a 0 to make 3 decimal places. So to get the volume of BA1 that was used, we shall get this, meaning this minus this, to get this one. If your initial value was 5 and your final is this, the volume of BA1 used would have been 20, but it's now 25 minus 0. It means the volume that was used is 25.10. Remember, as you repeat the same procedure, you keep on repeating the same procedure with the same water sample, do 2 and 3. Let's say if the next you got, let's say 25.00 and your initial was 0.00, what will be your volume of BA1 used? If let's say your next was 24.90, what would be, if the initial was 0.00 again, what would be your volume of this used? Please fill the table. Members, if you are careful, you're going to find that all of the values, if you are using the same solutions, will almost be the same. And for accuracy, make sure that the value is not bigger than the other. For the same solutions, now it is F with BA1. Let it be not bigger than this in difference. The difference between one volume to the other, or one value, experiment value to the other. To continue, we are now going to use water sample T and still determine we are going to still determine the volume. I suspended it already. I'm just going to fill up my soap solution back to 0. I want to use 0 as my initial value. Members, if you don't have enough solutions to refill back to 0, you can use any value as your starting point. So long as you record it in the table that this is my initial value or initial burette reading. So I'll adjust it back to 0. So it is back to 0. I'm repeating the other procedures. I'm going to pipette 25 of tea. I mean 20 of tea, because I used 20 for F. I'm going to get 20 of tea into a clean empty conical flask, and then call out procedure 3 of running a soap solution from a burette while shaking until when I get permanent lather. I'm not looking at where the solution is coming from. I'm looking at where it is going, making sure that all the drops of BA1 are falling onto the solution in the conical flask. While I shake, I'm adding a little at a time. No need for rushing, because I need my value to be as accurate as possible. I think I haven't made the permanent lather. I don't think the lather is permanent yet. I want us to have permanent lather. I want us to have permanent lather. Is the lather disappearing? I think yes. We are adding until when the lather does not disappear anymore. Is it permanent yet? It is also forming scum. You can see the scum, the white precipitates in the water sample. That is scum, meaning it is also hard water. With the other ends we talked of. And if we look at the lather, is the lather disappearing or permanent? If we can look at it. We do not have to babysit the lather not to disappear. It must be purely permanent. That even if you leave the solution stand for time, the lather still persists. Not being too careful that you don't shake the lather to disappear. It must be clearly permanent. I think not yet, because the lather still disappears. I think, has it formed yet? Is it permanent yet? We need to surely form lather that is visible and permanent. Is it permanent yet? Lather that does not disappear. We are on T. Our initial value, we started with 0.00. That was our initial burette reading. If we can confirm that the lather is permanent, we can go with that as our final burette reading. If we confirm it, if not yet, we can still add members. We still have the sub-solution in the burette. To me, I see as if my lather is permanent. So my final burette reading this time with the T, it is, let me bring it to the level of the camera, and my height. It is 12.5. If you look at it closely, it is 12.50. So we add a 0 because we said we recorded the values of the burette to one decimal place. So this means that the volume of BA1 used on T is 12.50. Can you people sit and rate what could be these other two values if the initial burette reading is this? Can you get us the volumes here? Remember, as we said, we repeated the procedures with at least 3 values for each water sample. We repeated the procedures until we ensure that we have permanent lather formed. And at the point when the permanent lather is formed is when we read off the new burette reading as our final burette reading. And we said that the final burette reading can help us get the volume of BA1 or sub-solution used. And we say it is obtained by subtracting the initial burette reading from the final burette reading. And we said that make sure that the value or the first value is not bigger or less than the next 2 values by more than this or below this. So this means the next value would have been a 12 point, let's say, 40. Even this one can be 12.40. This is when you are becoming more careful. The first value would have been bigger because you are not sure of when is the lather is to be formed, the permanent lather. And the next values are estimated to be a bit smaller than the first one. Why? Because by the time you do this one, you're now going to become more accurate. The extra drops you added after the reaction has been complete, this time you will not add them. That's why the second value and the third values will be a little more accurate and smaller than the first one. I don't think this first value would have been smaller than the last 2. Why? You cannot tell me that you were too accurate for the first time and you became reckless in the next values where you had to be more accurate and serious. Remember, as you're titrating, no need for rushing. Take your time. Add a drop. You have a number for 2 hours, just one number. So after getting these ones, to get the volume of BA1 that was required for T, we shall have the average volume. Now we are on the analysis part. To get the volume of this that was used for F, now on the analysis part, we shall have all of the values. Let's say if this value is 25, we are now looking for the volume of BA1 used on on F. So this means that we shall have these values. We have the 25.10 added to the next value, which is the 25.00, and with the 24.90 divided by how many values are they? We are getting the average volume divided by 3. So this means our value will be the sum of these ones divided by 3. And then you do the same for T. But even before we do that calculation, the values or the results are showing it clearly that water sample F requires a lot of soap solution BA1 to form permanent lather than T. This implies that T is a water sample that is more effective for washing since it does not waste the soap. Less of the soap is required from lather with water sample T. So this means this T is more required for use, more effective for cleaning or washing than F. Why? Because of the less volume of the soap solution used to form lather. So this means this is more preferred for use than this. Remember what we are doing? We are proposing a response. We are not giving a response. So basing on the practical skills you've attained from school, and I think they are a little related to these ones, and we all know how to manipulate these apparatus. We are online. This is Teacher Alan presenting. Don't forget to subscribe, to share, to like, to put in the comment sections the answers for this and the conclusion or recommendation you would make based on the simple explanation I've made. Which of these two water samples, F or T, should be used by the company? The washing service providers. We am online. Teacher, if you have questions as well, you can type them. So Mwangu's Emma is saying the lather is not permanent, meaning it's hard water. The lather will at a point become permanent. The lather will become permanent at a time when all the ions have been reacted with the stellate part of the detergent. I think I'm responding to you. Emma? With that, I think we can end the lesson and meet in the